Well, hello everyone. My name is Charlie Jeynes and I'm a STFC Fellow from the University of Exeter. And today I'm here to tell you about a nano engineering concept called dielectrophoresis. So that's dielectrophoresis. And why is this an interesting concept? Well, I spent quite a lot of my PhD in the clean room making these electrodes. You can see a few of them, one's there, and they're gold electrodes. And the idea here is to have two electrode edges and to trap carbon nanotubes between the two electrode edges. Here's a carbon nanotube here, with the idea of creating a biosensor. So you would flow molecules across the surface here and a current between the two, and you would detect molecules attaching to the carbon nanotube. So to get to that stage, what you'd have to do, or what I did do, is solubilize carbon nanotubes, which kind of look a bit like this. So you'd solubilize them in water and then track them between these electrodes using this process called dielectrophoresis. So just to conceptualize what we were doing, or what I was doing, I'm going to draw here my electrode, one of my electrodes. Here's the electrode edge, here's a pad so you can connect to it easily. And here's the other one here. And then you would connect these with an AC current. And then you would place a drop of water containing solubilized carbon nanotubes between the two electrodes. And then you would apply frequency and a voltage to create an electric field. And of course, there'd be a very high electric field between two electrode edges, which would decrease as you moved away from the electrodes. And when you applied that voltage and frequency, the carbon nanotubes within the solution will become polarized according to the AC current, the AC field. And this way you get positive charge on one side, negative charge on the other side, and then when the current flips over, it would be the opposite, and this actually creates a force. It can create it to go away from the two electrodes. Well, in our case what we wanted was for the electrode to become trapped, the carbon nanotube to become trapped between the two electrodes here. So this is quite a complicated system. So luckily for us, we have an expression which encapsulates all the different parts of this system. So we call it the dielectrophoretic force. So there's the dielectrophoretic force. And it's actually equal to the radius of the carbon nanotube itself, the permittivity of the medium, and in this case that would be water. It's also dependent on the real part of this frequency function called the Clausius-Mazetti factor, and I haven't actually got time to go into that, but that's just the frequency that you apply. Of course, the final part is the difference in the electric field generated, and this here is dependent on the voltage and the distance between the two electrodes. So from this equation you can see that if you can keep some of these parameters constant, you can actually manipulate the particle to pull out particles of different radiuses. So in this way we can actually select for types of carbon nanotubes within a solution, and this is a very interesting concept and a way of manipulating nanoparticles in a useful way. So there you go, I've explained the concept of dielectrophoresis. I hope you enjoyed the tutorial. I hope to hear you soon, and thank you very much for listening.